Yeah, so especially dimensional analysis is a technique that we are going to use in many calculation. And if you do not understand this, please let me know. So this is the last section of chapter one, and this is going to be the longest section. So I will not be able to finish this today. So I will finish this on Wednesday. So we are going to talk about these things, and it's under number and chemistry. So numbers are important in any science because we have to record our data as numbers. And also we are going to do calculations, and because of that, significant figures are important. And also when we do calculations, we are going to use the dimensional analysis. So, and also when you write a number, the most important part is the unit. So in this class, when you write a number, always there's a unit at the end. Like when you write 2.5, it doesn't have any meaning. It's just a value. But you have to specify the quantity by writing the unit, whether it's milligrams, grams, kilograms, liters, milliliters, like that. So because of that, first we are going to talk about different types of unit systems. Okay. In science class, as a practice, we are going to use the SI unit. The SI unit or system internal unit. So that's the internal system of units. And it's a modification of another unit system. So that unit system is called metric system. So there are some similarities and differences between SI and metric systems. So in addition to that, you may have familiar with some US units like gallons, Fahrenheit, calories. So that comes in the US unit system. So this slide is related to the SI unit, and also I'm going to add another column here and give you the metric unit. Okay. So some of the physical quantities that we are going to measure in a chemistry class or in a science class is like length. So we have to take the length of something. So if we're going to take the length of a object, we are going to record it as meters. So that's the SI unit. And also metric system has the same unit, it's meter. And abbreviation is simple M. So that's the abbreviation for meter. So if you write like 4.5 M, so this is the length of something. So it's 4.5 meters. And next one is the mass. So mass, SI unit system uses kilograms. And abbreviation is simple K, simple G. So kilogram is the base unit in the SI system to measure mass. And metric system, it's grams. So now we can see there's some similarity and differences between the SI and metric. The SI system is kilogram and metric system is gram. Difference is the first word. So that word is called prefix. So we can use these prefixes with any unit system. So it's prefix. So that prefix has its own value. Okay, so kilo is 1000. So that's the value of kilo. Kilo is equal to 1000. So we're going to talk about those prefixes in a minute, and it has its own mathematical meaning. And I don't know how many of you have noticed this. So you don't have a separate physical quantity on the side to measure volume. So one of the physical quantity is volume, and you don't have a separate unit, but in the SI unit system, the volume unit is derived based on the unit of length, and it is called cubic meter. Abbreviate as meter to the power 3. And we will talk about that too. Okay, so in the metric system, volume measured using liter. Abbreviation is capital F. So next physical quantity in the table is temperature. SI unit is Kelvin. How many of you heard the Kelvin temperature scale? Okay, so some of you already heard the word Kelvin. And abbreviation is capital K. So capital K stands for Kelvin, simple K is kilo. So metric is Celsius. You see degree Celsius symbol or Celsius. And time on both scales we use seconds. And You do not need to worry about mass free at this point. So we will talk about moles later. Okay, so these are the base unit of metric and SI unit system. So the base unit used in the metric system, mass, grams, length, meter, time, second, temperature decrease, degree of Celsius, and SI unit is the Kelvin. Amount of substance is mole, so volume is cubic centimeters or cubic meters. So we talk about the prefixes. So we can use these prefixes with any unit system, and these prefixes have its own meaning. So these are some of the prefixes. So there are a lot of prefixes. So I'm going to give you only 6, 7 prefixes that you are going to see regularly in my class with numbers. So those are mega. So mega, capital M, value is 10 to the power 6. So if you have a large value like this, 36. So if this is watt, instead of writing it as like this, we can write it as 1 megawatt because this number is equal to 1 mega. So kilo is 10 to the power 3. So I already explained that. So 10 to the power 3 is 1000. So when it comes to the decimal or the lower side, deci stand for 10 to the power -1 or 1 over 10. So centi is equal to 1 over 100. And milli stand for 1 over 1000. And micro stand for 1 over 6 zeros. And last one is in nano. So those are the 7 important prefixes that you are going to see in my class. So from mega to nano. Nano is 10 to the power 9. Actually, you are going to see it in chapter 6. So the advantage of these prefixes is you can find a relationship between the base unit and the unit with the prefix. So how many grams are in a kilogram? Does anyone know the answer? How many grams are in a kilogram? 1000. Okay, let me show you how to get that. So I'm going to start from 1 kilograms. The value of the kilo is 1000. 1 kilogram is equal to 1 kilo is 1000 and base unit is grams. So 1 kilogram is equal to 1000 grams. So if you want to find the relationship between 1 centimeter to the meters, 1 centimeter is equal to 1 centi is 10 to the power -2 or 1 over 100. So you can use it as this. Okay. So if you want to use it as 1 over 100, it's going to be like this. 1 centimeter is equal to 1 over 100 times meters. So now we can multiply both sides by 100. So 100 centimeters is equal to 1 meter. Okay. So we are going to use this type of equations. These are called equalities to convert a given unit into a new unit. So that's the advantage of these prefixes. So we are going to use it a lot later in this chapter. Okay, so that's the advantage of prefix table. There are basic units we measure in science. So some of those are mass and length. So mass is the measure of amount of material in an object. So SI uses the kilograms and the base unit as the base unit. The metric system uses the grams as the base unit. So length is a measure of distance. The meter is the base unit in both SI and metric system. So next one is volume. And let me explain the SI unit of volume, and that's cubic meters. So it's derived from the length. Because let's say we have a cube like this. It's a cube. Okay, so let's say length of this cube is 1 meter, width of this cube is 1 meter, and height of this cube is 1 meter. Let's say we want to calculate the volume of this cube. So from our math class, you know the equation, volume of a cube is equal to length times width times height. So now I have the measurements of each side. So it's going to be 1 meter by 1 meter times 1 meter. 1 times 1 times 1 is 1 meter times meter times meter. Meter to the power 3. So volume of this cube is equal to 1 cubic meter. This is the SI unit to measure volume and its cubic meters. So if we're going to relate cubic meters to liters, so let's say this is a tank made of 1 meter by 1 meter. So this tank required exactly 1000 liters. So 1000 liters is equal to 1 cubic meter. That's the relationship between liters and cubic meters. So you do not need to remember that. Okay, so again, you can see this cube is divided into 10. So one side is 1 meter, and 1 meter is equal to 100 centimeters. So which means one of these medium sized cube has 10 centimeters, and 10 centimeters is exactly equal to 1 decimeter. So now we have a small cube, a medium sized cube, and we have thousands of those in that large cube. So 1 cubic decimeter is equal to 1 liter. Again, if we divide this 1 decimeter cube into 10, which means 1 centimeter on one side, so this is going to be a very small cube. So this cube is going to be 1 cubic centimeter. So 1 cubic centimeter volume is equal to 1 milliliter. Okay, so some of you may have used this in the clinical setting. So cubic centimeter is sometimes we write it like this, or sometimes we write it like cc. So those who are familiar with the engine capacity in cc, that cc stands for the cubic centimeter. So that's the capacity of the cylinders in cubic centimeters or in milliliters, in other words. Okay, so when it comes to the lab, we have different glassware and equipment to measure certain volume. So one of the common items is graduated cylinder. So these are calibrated items, little bit of expensive. So normally we have 0 at the bottom and highest value on top. So sometimes it can be 10, 25, 50, 100, so depending on the volume. We have the highest value on top. So we can use this calibrated scale to measure volume. And also cylinders are calibrated equipment, so we can measure certain volume. And also there are a few other things in the lab. So we are not going to use burette. So burette is also a glassware that we can use to measure a certain volume. So there are some calibrated pipettes or volumetric glass to measure certain volume. Okay, so that's about volume. And now we are going to talk about the temperature scale. So I'm going to explain 3 different temperature scales. The first one is Fahrenheit, and Fahrenheit has a degree symbol. Second one is Celsius, and third one is Kelvin. Abbreviation is capital K, so there's no degree symbol with Kelvin. So we're going to understand these 3 temperature scales based on 2 reference points. And also we're going to talk about how do we convert temperature in between these 3 scales. So first one is the Fahrenheit. So my highest point is going to be the boiling point of water. So at what temperature what is going to boil in Fahrenheit? So does anyone know the boiling point of water in Fahrenheit? Any guesses? 212. 212, good. So what is going to boil at 212 degrees Fahrenheit? So what is the freezing point of water in Fahrenheit? 32 degrees. So that's the freezing point of water. Okay. So if we relate these 2 points to the Celsius scale, this is my Celsius scale. So what is the boiling point of water in Celsius? 100 degrees Celsius. Water is going to boil at 100 degrees Celsius, and freezing point of water 0 degree Celsius. Okay. So what is the difference between 212 and 32 degrees? I mean 212 and 32. 212 minus 32. What is the answer? 180. So 100 minus 0, 100. Okay. So based on these two gaps. Okay. So this tells us 1 Celsius gap is not same as 1 Fahrenheit gap, because there are 180 units in this region and it is equal to 100 unit on Celsius. So that gap is different. So it's not easy conversion. So based on these two gaps and the starting point of Fahrenheit, we can develop an equation to convert Celsius into Fahrenheit and Fahrenheit into Celsius. So 180 to 100 is the ratio between Fahrenheit and Celsius. Okay, so if you don't understand the development of this equation, you can simply drop it. So 180 to 100 is 9 to 5. So that's the lowest ratio. So this is going to be the equation. Temperature in Fahrenheit is equal to, so that gap is 9 to 5 ratio. So we are going to multiply that by the Celsius value. And Fahrenheit start from 32. And because of that, we are going to add 32. So that's the equation converts any Celsius value into Fahrenheit. So as an example, 0 Celsius, we can substitute 0 into this. So this part is going to be 0. So Fahrenheit value is going to be its value. Okay. So if we substitute 100 into this, so now it's going to be here is equal to 9 times 100 over 5 plus 30. So 9 times 100 is 900. 900 divided by 5 is 180. So it's 180 plus 32. And this 212. We have the correct value. So 100 degrees Celsius is equal to 212. So this equation is valid. So you can use this equation to convert any Celsius into Fahrenheit. Any question? Again, I can rearrange the same equation and derive an equation to find out Celsius value from Fahrenheit. So basically, I'm going to solve for TC from this equation. So this is how we are going to do it. TF, I know 5, TC plus 32. So my object is to isolate TC on one side of the equation. I'm going to subtract 32 from both sides. Okay, so now I have 9 over 5 TC. Okay, so that's what left on this side. So I'm going to write it on left. So this side is going to be TF minus 32. So my coefficient is 9 over 5. So I'm going to multiply it by the reciprocal of 9 over 5. So it is 5 over 9. I'm going to multiply both sides by 5 over 9. The equation is going to be cancels out. Now DC is equal to 5 over 9. TF minus 32 is within brackets. Okay. So this prioritize. So you have to do this calculation first and then multiply it by 5 and divide by 9. That equation convert any Fahrenheit value into Celsius. And both of those equations will be on front page in the exam, and you may get one question out of this. So whether it's going from Celsius to Fahrenheit or Fahrenheit to Celsius, you should be able to do it. So I will give you the equation. You're going to substitute the value and solve for the answer. Okay, so let's do a couple of practice problems. Okay, first question, 40 degrees Celsius equal to how many Fahrenheit? Second question, 140 Fahrenheit is equal to how many Celsius? Let me write two equations. F is equal to 905. If the Celsius is equal to 5/9. Anyone finish the first one? What is the answer? 104. Good. So what is the answer on second? Okay, so for the first calculation, which equation is required? One on top or the bottom? Top. So we are going to calculate the Fahrenheit. So it's already solved for Fahrenheit. So we are going to see first equation. It's going to be 905. So Celsius value is 40. We want to substitute 40 and plus 32. So 9 times 4 is 360 divided by 5 plus 32. 360 divided by 5 is 72. 72 plus 32 is 104. So it's going to be 104 Fahrenheit. Any question? Good. Okay, so for the second question, we are going to use the second equation because it's already solved for TC. So TC is equal to 5/9. Fahrenheit value is given, so it's 140. So 140 is going to be the parenthesis minus 32. So 140 minus 32 is 108. Okay, so 108, 5/9. You can do this calculation and it is going to be 60. So you can use your calculator and get the correct answer or use your math knowledge. Do you need more examples or is this enough? Enough or need more examples? Good. Okay. If anyone need more example, let me know. So I'll give you more and I'll show you how to get more examples. So that's our first two temperature scales. So we didn't talk about the third one yet. So now we're going to talk about the third scale. Third scale is the Kelvin scale. That will be third scale. Okay, my first question. Do we have any negative Fahrenheit values? Yes or no? Yeah. Do we have any negative Celsius values? Yes or no? If we check the temperature in your freezer, it's going to be around like negative 15 degree Fahrenheit, Celsius. There are negative values in both of these temperature scales. So like 30 minutes ago, I have explained how temperature is related to the energy. So kinetic energy is proportional to the temperature. Every matter is made of tiny particles, and all these particles has vibrations or motions or fast motions. So which means there's a certain form of kinetic energy. So the only thing that we can have is the those particles at rest. So which means no motion, no kinetic energy. So it's going to be zero kinetic energy. So temperature is the average kinetic energy of all the particles. So which means when particles are not in a motion, kinetic energy is zero. The average energy of all those particles should be zero. So temperature cannot be negative according to the scientific definition. So these two scales does not agree with this definition because there are negative values. So that's why we need the third scale. The lowest possible temperature on any substance is going to be the 0 Kelvin, and this is called absolute zero. which means if we can cold any materials until all those particles are going to be at rest, no more vibrations. So if it's completely frozen, then that temperature is going to be 0 Kelvin. And this is a really cold temperature and it's very difficult to achieve experimentally. So if we measure the same temperature on Celsius scale, so this is a Celsius scale. So that lowest possible Celsius value, which is going to stop all these motions, is going to be negative 273.15 Celsius. That's the lowest possible Celsius value. And it is very difficult to achieve. So scientists use the same magnitude for 1 Celsius and 1 Kelvin. From 0 to this point is negative 273.15. So that tells us from here to here, it's going to be positive 273.5. So which means what is going to freeze at 273.15 Kelvin. Same magnitude for 1 Celsius and 1 Kelvin. Does that make sense? Okay. So then from 0 Celsius to 100 Celsius, it's 100 unit. So then it's going to boil at 273 plus 100, which is 373.15. That's the boiling point of water in Kelvin. And for simplicity, in my class, you might not see this 0.15 most of the time. So you can simply add 273 or subtract 273 when you convert Celsius to Kelvin or Kelvin into Celsius. So if you're going to convert any Celsius value into Kelvin, you simply add 273. So temperature in Kelvin is equal to temperature in Celsius plus 273. That's an example. If we substitute 0 into this, 0 plus 273 is 273. Temperature in Kelvin, so Celsius plus 273, which means we add 100 plus 273, so we get the 373. So when you're going back from Kelvin to Celsius, you subtract 273. So that's the next two equations. So this one converts Celsius to Kelvin. And you can subtract 273 from both sides of this equation. You get the other one. Celsius is equal to Kelvin minus 273. So specifically, you're going to use these two equations in several places. So that's how we are going to convert any Celsius value into Kelvin or Kelvin back to Celsius. As an example, you can find these two questions. So what is the temperature in Kelvin equal to, let's say, 68 Celsius is equal to how many Kelvin? So 2 170 Kelvin is equal to how many Celsius? Did anyone answer the first one? 41. So temperature in Celsius is so temperature in Kelvin. So we are going to use that equation is equal to temperature in Celsius. So we're going to substitute Celsius into the equation. 68 plus 273. This is 341. Kelvin. Got no difference in 341. So what is the answer to the second question? Okay. So we are going to use the second equation, is temperature in Celsius equal to temperature in Kelvin minus 73. So our temperature in Kelvin is 170. And 273 equal to 177. What is the answer? Negative 113. Anyone or three? Any question? Do you need more examples? Yes or no? If you need more examples, go to the blackboards under worksheets and study guides. Click on chapter 1 and first worksheet. So temperature conversion worksheet chapter 1. So there are 25 questions in this worksheet between different conversions. Okay, let me give you one more example. So this is the equal to how many Kelvin? You do not need to remember any of these equations, so all four equations will be on front page. The answer. Actually, good job. Okay. So did I give you any direct equation between Fahrenheit and Kelvin? No, I did not give you any equation between Fahrenheit and Kelvin. So in that case, you are going to convert Fahrenheit into Celsius, and Celsius into Kelvin. So what is the first equation that you're going to pick from the list? Okay, so we are going to convert Fahrenheit into Celsius. So we need this equation for this conversion. So we are going to use this. So it's going to be 5/9, 68 minus 32. It's going to be 36. 5/9. Okay. 9 times 1, 9 times 4. So 4 times 5 is 20. So this is equal to 27. That's the Celsius value equal to 68 degrees Fahrenheit. So I pick numbers that are going to cancel out. The next one is Celsius into Kelvin. So we are going to use the last equation to convert Celsius into Kelvin. So equation Kelvin. Now we are going to substitute 20 equation and add 273. So that's 293. That's the Kelvin value. I think that's enough. Okay, let's go to the next topic. So we talk about all those, and you can find all the information in the next couple of slides, and also all the equations. So these are the Celsius equation. And we talk about the unit of energy. So let me quickly go over the unit of energy. So this slide is supposed to be with the energy section. So we talk about two different forms of energy. So unit of energy or SI unit of energy is joules. An abbreviation is capital J. So this is the SI unit. And also we have another unit, and it is called calorie. Abbreviation of calorie. CAL. Okay, so that's the relationship between calories and joules. So 1 calorie equal to 4.184 joule. That's the relationship between calories and joules. So joules is a combination of several other SI units. Okay, so joules has kilograms, meters, and seconds. So it's going to be kilograms, meter squared, or per second. 1 kilogram meter squared hours per second is equal to 1 joule. That's why we don't have a separate. I mean, it's separate. We have a separate symbol, but it's a combination of base units of SI. So this calories is developed based on the amount of energy required to increase the temperature on 1 gram of water by 1 Celsius. So let's say this is at 20 Celsius. So we are going to increase the temperature on 1 gram of water by 1 degree Celsius. So 20 to 21 is 1 degree Celsius. This is 1 gram of water. To increase temperature on 1 gram of water by 1 Celsius, we need a certain amount of energy. This energy is equal to 1 calorie. So nutritional calories, normally you express like I burned 300 calories or I had like 500 calories. So that's not same as this calorie. So it's called nutritional calorie. So 1000 small calories is equal to 1 nutritional calorie. So when you read a nutritional label, calorie value we are going to see is big calorie or kilojoule. Kilojoule. 1 kilojoule is equal to 1 nutritional calorie. This is what you see on the nutritional level. So normally energy values are going to be large values. Okay, so always it's going to be large value. So that's what you're going to see on this slide. So you have the definition of 1 calorie and equations. Okay, it's time to talk about the density. So density is also one of the important physical property. And is it intensive or extensive? Density, is it intensive or extensive physical property? Anyone? It's intensive. So density does not depend on the amount of substances. So we can use density to identify substances like water. Density of water is 1 grams per 1 cubic centimeter. So whether it's 1 liter or 1 glass of water, it has the same density. So those type of properties are called intensive properties. So I already briefly explained how to calculate density. So density can be calculated using other physical properties. And those are mass and volume. Okay. Let's say we want to calculate the density of a liquid. So if you want to calculate the density of a liquid, the required two variables are mass and volume. So we can simply read the volume of a liquid using a graduated cylinder. Okay. So in order to measure the mass of a liquid, we can follow a simple calculation like this or simple experiment like this. So we are going to take an empty graduated cylinder and take the mass. So mass of empty graduated cylinder. So let's say this is equal to 12.65 grams. So then I'm going to add my liquid. So this is a calibrated cylinder. So I'm going to add the liquid until it reaches to roughly 8 to 9 milliliters, like this. Okay. So now I have the mass, I mean the liquid and the graduated cylinder. So we can take another measurement. Mass of liquid plus graduated cylinder. Let's say this is equal to 90.25. How do we find the mass of the liquid? We subtract the two. So when we subtract the lowest value from the largest value, we get the mass of the liquid. So mass of the liquid is equal to 90.25 minus 12.65 grams. It's going to be 6.6 grams. Okay. The next one is the volume. So we can read the volume directly from the graduated cylinder. So we are going to keep our eye at the same level with the meniscus. So this is called meniscus. So it has this concave up shape like this. So we are reading the bottom of the meniscus. So that's the actual volume. So let's say volume of this liquid is 8.76 milliliters. So now I have both physical properties that require to calculate density. So I can calculate density using density equation. So it's mass over volume. So mass is 6.6 and volume is 8.7. And this is in milliliters. So what is the answer? 6.6 divided by 8.7. It's going to be a
Log 7.5861.
So 0.758, okay, I'll round it to 0.76. The unit is going to be grams per ml. Okay, so if we use 8 milliliters or 16 milliliters, this answer is not going to change. So it's going to be the same value, or close to a value like that. Because density is one of the intensive properties. So it's the mass of unit volume. So since we divide by the volume, so it's going to be the mass of a unit volume. The mass of a unit volume is always same if it's the same liquid. So that's the advantage of intensive properties. So we can compare different liquids and identify it based on the density value. We can use several intensive properties like that. So you're going to do this experiment in lab 2 week after next. Okay, so we're going to do the same experiment in lab 2. Okay, so densities are pre-calculated values. So depending on the substance, we can find the density. Again, density depends on the outside temperature because volume is highly dependable on temperature. And therefore, when we express the temperature when we express the density, normally we express for 25 Celsius, which consider as the room temperature. And you can see there are some substances as lower densities like air and wood or some lower densities. And there are some high density materials like gold, iron. So there are some materials like mercury. So there are some high dense material. And water has the 1 grams per cubic centimeter. So cubic centimeter is same as 1 milliliter. 1 cubic centimeter is same as 1 milliliter. So therefore, unit of density is always unit of mass over unit of volume. So it can be grams over ml or grams over cubic centimeter. So it's the same thing. So at this level, it's given for grams per cubic centimeter. So density of water is 1. So if we're going to add a piece of wood into water, is it going to float or sink? It's going to float. So if the material that we are going to add into a liquid has a lower density, like wood, balsa wood, it's going to float. And if you add a piece of nail, it's going to sink. So you can see iron 7.9. So it has a higher density than the density of water. So it has more material in a unit volume because of the more mass or more unit mass going to sink. Okay, so I think it's a good point to stop the lecture. Any question?